Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Rishika welcoming you, all my grade 11 elite math students, to term 1. And today we are starting with lesson 1.2 Vectors in the Coordinate Plane. Today's session is going to be part 1. It is going to be a long but very useful video. Make sure you are stayed glued to the video till the end, because towards the end we'll be covering some textbook important questions. So stay tuned and let's start with our learning objectives. Our learning objectives of this session would be to represent and operate with vectors in the coordinate plane, to write a vector as a linear combination of unit vectors, and as I told you, towards the end we solve some vector problems from the textbook which are important. So stay glued till the end of the video. A humble reminder, a kind request. If you have not subscribed to the channel yet, please do that so that it motivates me to make more and more videos for you. Also press the bell icon so that you don't miss future videos from me on math for grade 11. So this is going to be a lesson menu for today. We'll start with some vocabulary words. We'll then move on to the key concept to know about component form of a vector. We'll be solving examples on the same. We'll learn about magnitude of a vector in the coordinate plane along with vector operations. You'll also learn in today's session how to write a unit vector with the same direction as a given vector and as a linear combination of other unit vectors. So all of these stuff coming up. It's going to be a long video. Stay glued till the end of the session so that you don't miss the important questions. Okay, so let's check on you for the last lesson. Have you prepared? Have you revised that one where we introduced vectors to you? So which of the following represents a vector quantity? So it's a multiple choice question. Similar will come in your exam. Have a look. Take a minute. There are 4 options, A, B, C, D. Tell me which one is a vector quantity. So if you look at option A, it just talks about magnitude of 55 miles per hour. That's the speed with what the car is driving. If you look at option C, it's the temperature of a cup of a coffee. So it may be, like 40 degrees or 50 Fahrenheit, like that. And if you look at option D, the wind is blowing at a speed of 30 knots. However, the option B looks like the odd one out, where you are given the magnitude of the force as 40 newtons and the angle also at which the force is inclined, which is 30 degrees. So it clearly gives the magnitude and the direction both. So B is your answer. It's a vector quantity, because by definition of a vector quantity, it has both magnitude and direction. So that was an easy one. Coming to the vocabulary for today: component form, unit vector, and linear combination. The meaning of these 3 words are going to be clear to you in today's session. So stay glued, stay focused, and let's start with the first key concept. Okay, so the first key concept talks about component form of a vector, which is very, very easy. It involves vector subtraction. So if you are given the initial and terminal points, for example, the initial point of the vector AB is given by point A, x1, y1, and terminal or final point B is given by x2, y2, then the component form of the vector AB. So if you want to write your vector AB in component form, it will be the x coordinate subtracted. So terminal minus initial, always you do that. So x2 minus x1, comma y2 minus y1. You can also have a look at the graph. So if this is the initial point A, this is the final point B, then x2 minus x1 and y2 minus y1 are the x and y components. So accordingly, component form of the vector AB would look like this, where you do vector subtraction. So let's solve some questions over this form. Pretty easy and simple question to begin with. That's our example 1, where you express a vector in component form. You are given the 2 points, the initial and final. Just subtract them. Use the component form formula that you've just seen in the last slide. Put in the values carefully. So the only mistake you could do here, only error that you could commit would be a sign mistake. So just be careful. I'm telling you in advance so that you don't do that mistake ever. Okay, so x2 minus x1. This is x2, which is 1. This is x1, which is 1. So when you subtract, they cancel out and give you a 0. Then your y2 is 3, your y1 is minus 3. So when you subtract, minus minus changes to plus. So this is 3 plus 3. That's why it gives you 6. So that's the component form. That's your answer. Pretty easy. If you've understood it, try this question in your notebook. Take a minute. Options are A, B, C, D. Tell me the correct one. Use component form. How much is x1? How much is y1? How much is x2? How much is y2? I want to know from you. So the initial point gives you x1, y1. So this is, let's change color. x1 is minus 4, y1 is minus 3, x2 is 5, y2 is 3. So let's plug in 5 minus of minus 4. I want you to check your answer with me. Don't just copy what I'm doing. Do it yourself so that you get the confidence and you do it correctly. So 5 plus 4 and 3 plus 3, that's going to be your components. So 9 and 6. So definitely your answer is going to be A. How many of you got that correct answer? Let me know in the comment section, and very well done to all of you. Anyone who did any sort of mistake, please learn from it and don't repeat it in your exams. Let's now move to the next key concept, which talks about magnitude of a vector in the coordinate plane. So again, you have an initial point and a terminal point for the vector v given to you. Then the magnitude, as you know, as you did in the first video for the first lesson, would be coming from the Pythagoras theorem. So you will take the sum of squares of the component. The first component is x2 minus x1, which is the x component, then y2 minus y1, which is the y component. Take their squares, add them up, and that's how you get magnitude. Very, very important formula. I'm sure you'll be getting some questions, and if v has a component of form a comma b, you are taking it from the origin, then it will be this value. Now I want you to recall that if I write something like this, it means magnitude. So the vector inside, the vector v written with the bars around it denotes magnitude of the vector. So magnitude of vector v is denoted by this symbol, which is square root of sum of squares of the component. Pretty important question. You'll be getting a question in your exam on this formula. So let's see what kind of question to expect from magnitude of a vector in the coordinate plane. Okay, so here you are given initial and terminal points. Step 1 would be to find the components and use the magnitude formula. So x2 minus x1. Let's see. This is the first point, x1, y1. This is x2, y2. So you know x1 is 1, x2 is 1, y1 is minus 3, y2 is 3. So just subtract x2 minus x1. It will come out to be 0. And put in the values. Second one is 6. So 6 square and its square root would be square root of 36. So 6 is the magnitude, which is the answer. Try a problem now yourself, and you may also check your solution afterwards. So let me know how many of you solved this in your notebook using the magnitude formula and got the correct answer as B, which is 7. And if you got it, then pat your back. Well done. You have got the concept well. Let's move on to the next concept, which is very simple and easy, vector operations. It works like algebraic operations where you do addition, subtraction, multiplication. So 1, 2, and 3, these three operations you'll be doing. So when you add the vectors, you just add their components. So x component gets added to x component, y component gets added to y component. Don't mix them, and that goes similarly for subtraction where you subtract the x and y components. Then you do scalar multiplication, just multiply the scalar, distribute it, and get your answer. Let's see a question. What kind of question to expect? Pretty simple. You have to find 2 times vector w plus y. Vector w in component form is given, vector y in component form is given. We're also given another vector, but we are going to use it for another part. Just substitute and multiply. So when you are multiplying 2 times w, it distributes. It works like distribution. So 2 times 2 is going to give you 4. 2 times minus 5 is going to give you minus 10. Now add the components. 4 plus 2 and this plus this. You are adding x with x, y with y. So 4 plus 2 would give you a 6 and minus 10 plus 0 would give you the same number. So that would be your answer. Let's do another part with z inverse. So here 3y minus 2z. So that means you are going to use this one and this one. Just put the distributive law and substitute the correct values. So 3 will be multiplied with 2, 3 will be multiplied with 0 and so on. So let's distribute and it comes out as 6, 0 plus 2, 8. Add 6 plus 2, so you are adding component wise. 0 with 8. So you get 8, 8. That's your answer. Time for you to try a problem yourself. So solve in your notebook, get your answer, check and tell me how many of you got B as your answer. So just do the scalar multiplication. Let me give you a hint here. So 3 times V means, let's substitute, this is V, plus 2 times W means this is this. So when we multiply, when we do scalar multiplication, we obviously do the distributive. That's why these arrows. So 3 multiplied with 4 would give you 12. 3 multiplied with minus 1 would give you minus 3. Then 2 multiplied with negative 3 would give you negative 6 and 10. Now you take the components. 12 goes with this goes with this. So 12 minus 6 minus 3 plus 10. So this is going to give you 6. 10 minus 3 is 7. So that's why your answer is B. I hope everyone got the same answer. Double check. Let me know in the comment section if you're getting your answers all correct for the guided practice. Another important question that should be coming for your exam, which will be on unit vector. So when you see the word unit vector written in the question, remember you have to use this formula. That means unit vector is equal to the vector divided by its magnitude. We have seen this formula in the first lesson also, and by definition unit vector has the same direction as the given vector. So the given vector has 4 as the x component, minus 2 as the y component. Let's find its magnitude. Use the magnitude formula. That means you are going to use this formula and you are going to take the square root of 4 square plus minus 2 square. So this is square root of 20 and the vector is 4 comma minus 2. So you can just use now the scalar property and distribute this on both the components. So when you do that, rationalize the denominator, cancel out the common factors, and it will come out to be finally the x and y component as this. Now how did we rationalize? If you have forgotten, let me remind. Whenever you have a radical sign in denominator, you rationalize the denominator, you get rid of that radical sign by multiplying the same in the numerator and denominator. So 2 over radical of 5 will be multiplied with radical 5, radical 5. Why we do that? This process is rationalization because when in the denominator square root 5 will be multiplied, it will in the next step get rid of the radical sign because this is same as 5. So it will become this value as you see here. Similarly, here also the radical is removed. So rationalization is important and therefore your final answer would be the unit vector, this one. So if you see radical sign in denominator, don't forget to rationalize before you give your final answer. After you got your vector, you can check your answer if you have time by checking for the magnitude. Use the magnitude formula. Take the x component square, take the y component square, combine the terms and see. Is it coming as 1? Yes, it is. That means your answer is correct. The unit vector you found is extremely right, and that's how you check your solution. Now try a problem yourself. I'm going to give you a minute and then we'll check your answer. So step 1 would be to find magnitude of W. That means you take the square root, 5 square and minus 3 square. do your calculations and check your answer. So this is coming square root of 34. Okay, how can we just simplify it? 2 times 17, so nothing much we can do, it will be as it is. And now you will find the unit vector as the vector 5 comma minus 3 divided by its magnitude. So it will be 5 comma square root of 34 minus 3 comma square root of 34. Now there's a need to rationalize. I hope you all can see, because in the denominator you have radical. So rule is multiply with the same one and get rid. So I do to the numerator and to the denominator the same thing and get the answer as this. So which option is matching your answer? Let's check. Oh, it's C, right. So C is your answer. Let me know in the comment section how many of you got C as your answer and did the correct step. Okay, now let's do an important question on linear combination of unit vectors. So you are given a vector DE with the initial point. Let me highlight with a different color. So the initial point D is given, the terminal point E is given. You need to write this DE as linear combination of vectors ing. Very, very important. Now first you are going to find the component. That's step 1 when you do linear combination. So use the component form. Substitute the point. So here x1, y1 is -3, -3. x2, y2 is 2, 6. So just substitute these points here. Get your components, so 5, 9, and then you rewrite the vector as the linear combination of standard unit vectors. What does that mean? So you write your component form, and with the x component, this is x component, this is y component. You all know that, right? X comma y, that's how you write the vector. So with the x component, I is the unit vector. This is the horizontal along the x-axis. J is the unit vector. That means it is magnitude 1 along the y-axis. So when you are writing as linear combination, with x component you take I, with y component you take j and add them up. So this formula is very important. This formula is actually your formula for linear combination of standard unit vectors. So the standard unit vectors are I and j, and when you get the components, you just put them in this form: ai plus bj, where a is the x component, b is the y component. So that's your answer. Let's check a question now. Let's do it together just to make you more comfortable. So this is my initial point x1 and y1. This is x2, y2. So we need to first find the component form. Let's do that. So we need a comma b, and we'll write it as linear combination in this form. Okay, so x2 minus x1 comma y2 minus y1, that's what we need. So x2 is minus 1 minus of minus 4, y2 is 5 minus 3. So this is minus 1 plus 4 and 2, which is same as 3 comma 2. So now you've got your components. You need to write them in the linear combination form. So this will be 3i plus 2j, because 3 is the horizontal component, 2 is the vertical component. So how many of you got D? Let me know in the comment section and did this question correct. Now, as I promised, now is a textbook problem. We are going to do this problem using component form, using the same method that you did in the previous questions. So here the vector is given to you. You need to find unit vector. Unit vector means magnitude should be 1. So let's apply magnitude formula, and it will give you x6 square plus minus 2 square. How much is this? 36 plus 4, which is square root of 40. Now how can I write this in a better way? 2 times 2 times 2 times 5. So I take this 2 out. So 2 times square root of 10. This is what I get. Now once you have the magnitude, we need to write the unit vector. So unit vector will be, the unit vector W would be the vector 6 comma minus 2 divided by its magnitude. That means the magnitude of W, right? So which formula are we using? I hope you can recall. Unit vector is the vector divided by its magnitude. This formula. Okay, for the definition of unit vector. So 6 comma minus 2 would be divided by 2 comma radical sign. Now this is 6 over this. Just do it individually on the x and y. Now you see radical sign in denominator. That means you are going to need to rationalize. Let's cancel common factor first. 3. This goes with this. So the final thing is 3 over square root 10 over minus 1 over square root 10. But I still need to rationalize because I don't need the square root or the radical in the denominator. So 3 square root 10 over 10 comma minus square root 10 over 10. Is it the correct answer? Yes, very well done. Okay, in a similar way, try this as your homework. Question number 4B on guided practice. This is taken from your math book, and check and tell me how many of you got this correct answer. So that brings us to the end of today's session. Coming up next on my channel would be the part 2 of the video where we'll be covering more and more questions from your math book. So stay glued to the channel. If you like this video, give it a big thumbs up, share with your friends who are also in grade 11 and will find this video useful for vectors. And stay glued and don't forget to press the bell icon so that you don't miss part 2 of this coming up video. See you in my next video. Bye students.